Okay, so good morning, students. I hope I'm audible. Yes. Am I audible or not?
Yes, ma'am.
Fine. Fine. So we can start, right? We are discussing about epidemiology. We are discussing about its importance in disease forecasting. We discussed about disease forecasting in the last lectures about plant pathogens and why it is important and for what are the requirements of a disease forecasting and what for how many some examples where the disease forecasting models have been developed, right? So this we have already discussed, right? So we can quickly revise. Who will tell me what is weather forecasting and what is disease forecasting and how they are similar? Come on, hurry up. What is weather forecasting? Kshitij, where are you? Is there or not? No, he's not there. I've locked the meeting right now because after at least 5 minutes are sufficient for you guys to join. And every day I see people join very late. So today I've locked the meeting and students cannot join without my permission. So there are only 15, 14 students, rest all are late, right? So that's why I've locked meeting. Otherwise, I never lock it because I always think that you guys join on time. This is just because you guys never do, right? So that's why I've locked the meeting. Yes, Athoiba. Athoiba, please unmute yourself.
Yes, ma'am.
Yes, Athoiba, what is weather forecasting? Can you tell me? Weather forecasting.
Ma'am, I think it's the application, uh, to predict uh
Mm-hmm.
the atmosphere for
Yes,
a given location.
yes. Like a weather forecasting, like what will be the temperature, what will be a rain, if there are chances of any kind of storms or any other thing that is being predicted there, right? Okay, then who will tell me what is disease forecasting? Manaswani, yes.
Ma'am, so it's basically a way of predicting a particular disease outbreak or epidemic in the future. And there's a team of people who usually do it. So it's a pretty complex method, but that's what it is.
Yeah, it is. Okay, fine. Okay, so now who is going to tell me about why disease forecasting is important and why we need to forecast a particular disease? What is the requirement? Yes, Kshitij, unmute yourself and answer this question. This time I'm again allowing you guys, right? बहुत लोगों ने लेट ज्वाइन किया मैंने अलाउ किया नेक्स्ट टाइम आई एम नॉट गोइंग टू अलाउ यू अगर आप 5 मिनट के बाद ज्वाइन करोगे क्लास 5 मिनट इज अ सफिशिएंट टाइम राइट क्षितिज अनम्यूट योरसेल्फ
Yes, ma'am.
yes Kshitij tell me why disease for what is the use of disease forecasting if we are able to forecast a particular disease maybe 1 week earlier or maybe 10 days earlier how this is going to benefit farmers. Come on Kshitij unmute yourself.
Uh,
हाँ बताओ.
mm, ma'am, by
अच्छा एक चीज बताओ क्षितिज वेदर फोरकास्टिंग का क्या यूज होता है जैसे हमें पहले से पता चल जाता है आज स्नो स्टॉर्म आने वाला है या फिर आज कोस्टल एरियाज में सी स्टॉर्म आने वाला है तो उसका क्या फायदा है बताइए अगर हमें पहले पता चलता है व्हाट इज द यूज.
ma'am, if we get it know earlier, we
यस
um,
यस टेल मी अगर हमें पहले पता चल
then
जाता है तो हम क्या कर सकते हैं.
um, then we have then the people which are living in that area can um, change
Can we
migrate
move
from
to
that.
some further places, right, Kshitij? So उसका ये फायदा है कि we can alert people and we can get that area, we can ask people to leave that area and we can transfer those people to some safe place, right? So we are saving people. Similarly, disease forecasting का आप बताओ, relate करो, correlate disease forecasting अगर हम पहले कर सकते हैं तो क्या होगा, बताओ मुझे. Yes, क्षितिज बताओ.
मैम basically by
Come on क्षितिज, you know it, right? बताओ. क्षितिज unmute.
by that
बोलो. हाँ हाँ क्षितिज, I'm listening, please speak. क्षितिज, you are in BSc final semester, right? So इस moment में I expect answers from you. I've given you enough hints. I'm just talking in the simplest possible language. I'm trying to correlate with the day-to-day examples, and if still you can't answer, then this is, I don't know how to proceed with this, right?
ma'am by um, um, for weather forecasting like temperature, relative humidity, rainfall. So basically, it during crop season it can identify um, and and the intercrop can be measured, and a computerized version which is black class which is developed in United States of America.
Kshitij, रुको, you don't need to read from anywhere. Kshitij, just tell me, if coronavirus जो pandemic अभी चल रहा है उसको हम 10 दिन पहले बता दे कोई हमें कि नेक्स्ट वीक से कोरोना वायरस स्टार्ट होने वाला है, तो क्या करेंगे हम? टेल मी, व्हाट विल डू? यस क्षितिज, आई एम आस्किंग यू स्टिल. अभी थर्ड वेव के बारे में पहले से प्रेडिक्ट हो गया था, तो फिर क्या किया गवर्नमेंट ने? क्या किया बताओ मुझे.
मैम कोविड सेंटर्स वैक्सीनेशन के लिए
यस,
पीपल को वैक्सीनेशन करवाने के लिए बोल दिया, और
हाँ
बेसिकली और लॉकडाउन लगाया था,
राइट. सी क्षितिज, यही कोरिलेट करना है आपको डिजीज फोरकास्टिंग प्लांट में भी. अगर हमें पहले पता चल जाएगा कि डिजीज होने वाली है, तो जो ग्रोअर्स है वो क्या करेंगे, वो प्रिवेंटिव मेजर्स ले लेंगे, राइट? जब वो प्रिवेंटिव मेजर्स ले लेंगे तो जो नुकसान होगा डिजीज से वो कम होगा, राइट? द लॉसेस विल बी लेस. So we need to just correlate the things which are happening around a similar way, right? Jैसे COVID, what happened in the, because we knew the third wave is coming, so they closed the schools, they closed the colleges again. They again they started with the booster dose. They again started that work offices will work with the 50% capacity. They closed the malls, they closed the theaters. Why? Because these were the precautionary steps they started taking, because they knew that these things will lead to the more transmission of the disease, right? So at least by taking these preventive steps, they can reduce the infection rate, they can reduce the number of the people who are going to get infected by a particular disease, right? So similar is the case of pathogens, plant pathogens also. If we are able to predict a particular disease ahead of its occurrence, right? So that means we can ask farmers to take some steps to reduce or to minimize the losses which can be, which can occur if the forecasting was not there. सो इसका मतलब है कि कोई भी डिजीज अगर हम फोरकास्ट, जैसे हम वेदर फोरकास्ट करते हैं, तो वेदर फोरकास्ट बहुत सारी लाइफ्स को सेव कर सकता है अगर वी इमीडिएटली टेक सम एक्शन, स्पेशली इन केस ऑफ सुनामीज और सी स्टॉर्म्स और सच थिंग्स। अभी लास्ट ईयर इंडिया में और अराउंड इंडियन एरियाज में हुआ है ये, सी के द एरियाज और कोस्टल एरियाज दे वर अलर्टेड फॉर सम स्टॉर्म्स और सम दोज थिंग्स, so those areas were vacated very quickly and people were saved. Otherwise अगर नहीं होता ये सब तो more we would have lost some lives, right? So anything which we are able to predict earlier will definitely help us to reduce the losses or to reduce the number of the lives that otherwise will lost, right? So this is why, that is why disease forecasting program और weather forecasting, आप दोनों similar चीजें ही हैं. It is just that weather में हम सिर्फ weather ड्रास्टिक चेंज या वेदर के बारे में फोरकास्ट कर रहे हैं, टेम्परेचर कितना होगा, कितना ह्यूमिडिटी है, कितना प्रेसिपिटेशन है. And disease forecasting, we are forecasting the similar events for the pathogen or a disease occurrence in a particular area, right? Okay, Shivani, tell me what are the important factors that we need to study for a disease forecasting? Shivani, can you hear me? Guys, I'm just trying to tell you everything in a very simplest, easiest possible way. I mean, मैं बहुत I'm just trying very hard actually. मुझे ये लगता है, और that's why the 10th time I'm asking the same thing again and again, so that you guys understand, so that you guys actually I don't want you to cramp the things and put those things and reproduce those things on the papers. I want you to understand. अगर 5 महीने बाद भी अगर आपसे कोई डिजीज फोरकास्टिंग के बारे में पूछे तो आपको पता होना चाहिए. दिस इज फॉर योर ओन नॉलेज, राइट? ये सिर्फ एग्जामिनेशन की पॉइंट ऑफ व्यू की बात नहीं है. इट्स नॉट अबाउट ओनली एग्जामिनेशन दैट आपने याद किया, यू क्रैम्ड इट, यू प्रोड्यूस्ड इट ऑन द पेपर, दैट यू ऑल वेरी वेल डू, आई नो, राइट? It is not about that. It is about the understanding. It is about at least when you've studied some course, तो उसके बारे में बेस मैं बहुत कॉम्प्लिकेटेड चीजें पढ़ा भी नहीं रही हूँ आपको. All I want is you to just remember the small things, the basic things in the course which I'm teaching you. Otherwise, there's no use of this course. I'm telling you, right? Yes, Shivani.
Sorry, ma'am, I wasn't able to unmute.
Mm-hmm.
So, for disease forecasting, the basic thing is the disease triangle.
Mm-hmm. Okay.
The which like the three factors: host, environment, and pathogen interactions, which will let us which will with which we will be able to assume what can be the how can there be a transmission, and what can it be caused.
Okay. Yes. See, the disease triangle, when we last year also when we studied disease, right? The first thing in my first lecture I discussed about was the disease triangle, right? Again, I'm telling that for a disease to take place, suitable environment, susceptible host and virulent pathogen is very important, right? So again, for a disease forecasting, we need to study these factors. We need to study the environmental factors. We need to study the host factors. We need to study the pathogen factors also. And this I mentioned last time, this also, that disease forecasting is not a one-day thing or a one-year thing. Maybe we need to study a particular disease for at least 5 to 10 years or 5 minimum years, and then only we can predict a particular disease by studying all the factors, right? So disease forecasting is not a one-day event or a two-day event or a one-year event. It requires a lot of work. Data is being carefully studied by the people or the scientists, for many years, right? It is a collaborative kind of a work, right? Whether variables will be provided by the weather forecasting team, then those correlations will be studied by the scientists, that how disease is progressing with the change in the weather variables, or with change in the temperature, with change in the humidity, with change in the soil temperature, for example, right? So all those factors are very minutely being studied for a number of years, and these days computer-based programs are available for these. All this data is being fed in the computer. There are computer-based programs which are made, and then we feed, if we feed the present data or present situations or weather situations or a vector or whatever pathogen situations, so that computer is going to predict that okay, this disease might take place in a few days time or whatever time, right? So disease forecasting is a very important in a disease management. When we talk about a disease management, the disease forecasting definitely plays a very important role here, right? So okay, so today we are going to talk about, this is the last topic for the disease epidemiology. So we discussed last time about the disease forecasting, about the fungal and this bacterial pathogen. So today we are going to discuss about viral pathogens, right? So how disease forecasting is being done in the viral pathogens. Okay, so there are certain examples where there number of people, they have started studying about the disease forecasting in a very early time, right? Why? See, uh, why people require to make a disease forecasting only if the disease is actually causing lots of losses. So when disease is occurring every time and every year, right? Continuously for 3 to 4 years, it is occurring every year and it is causing losses more or less similar than last year or maybe similar throughout the year, right? So then people think, okay, now since this disease is causing losses and every year it is occurring, so we need to do something, right? If we can forecast it um, uh, accurately to certain levels, so definitely a management or losses can be, which are being caused by a particular disease, can be reduced, right? So earliest model which predict plant virus epidemics, they were based on the insect vector population dynamics and weather. Why? It is very easy, right? We know the plant pathogens, they are, or viral pathogens, it is important that they should be carried out by certain vectors, right? So the mostly those models were based on the vector population in a particular area and the weather. Whether how, see, here the virus is, or they are not studying basically the virus or how virus is changing with the weather variables, because virus cannot multiply. It is there in the live host, but the vector population is definitely changed with change in weather conditions, right? In one weather, they are more or particular, there is some favorable temperature for that, in which they multiply. So that correlation they are going to study here, right? So what they did when they found that a vector population at a particular temperature is actually more, or particular precipitation it is favoring, so then they can correlate that there are chances that this disease epidemic can take place if particular virus is transmitted by that vector. So this is how they studied, right? Vector population and the weather. So first they were in England in around 1953, where series of models of sugar beet yellows disease, which is called sugar beet ecosystem, were developed. So the ecosystem, as I told you, like we have an ecosystem, right? Ecosystem. Similarly, there is a term given a ecosystem where pathogen is interacted with the host in some particular environment, which is favorable for both, right? So they were developed in response to changing cultural practices and control options. Here, the after 2 decades afterwards, again, they some people, they constructed a simulation to predict spread of subterranean clover stunt virus by cowpea aphids over in clover pastures in Australia. Then again in Japan, there was a rice swath virus in a rice population. So they studied this the population model for its green rice leaf hopper vector. Again, to develop a predictive simulation model for the rice swath virus, right? So here we are using one term very commonly, that what is simulation or a simulation model, right? So simulation model is basically it is a computerized model basically, right? Which is based on the real life conditions and then solved on a computer. Simulation modeling basically, we create and analyze a digital prototype of a physical model to predict its performance in the real world. So it is being used, simulation models are very commonly being used in the disease forecasting system, or even in a human disease forecasting and in a plant disease forecasting system, right? Then again we had in Canada again the Fraser this was a group of people. They developed a model to predict spread of alpha mosaic virus by T apid in alpha, right? Then most of the early models were very deterministic, focusing only on the temporal virus spread, temporal with temperature, how the virus is spreading, with the weather condition, or with one particular variable. They were not studying two or three variables at one time. They were focusing on one variable, maybe with the temperature, maybe with the rain, or maybe how with one weather variable this is spreading, right? So what it takes to predict plant virus epidemic. So how we can do that, right? So first we need to identify the pathogen, right? So this definitely we need a lot of factors which affect the pathogen. For example, virus, host, vector, and environment. So we need to study all these factors to know about a particular ecosystem of a particular pathogen, right? So we'll study all these factors. Then diverse information is required about nature and disposition of the primary infection source, right? So that means how the virus spreads from infected to healthy plant within a crop, then how it spreads over a distance to invade new sites, and then how it survives outside the main growing period, right? Because plants, especially the annual plants or the seasonal plants or vegetables which we grow, they are for a particular period of a time. They are not like a perennial. They are not like trees that they'll be available throughout the year. So how does the virus survive when the plant is not there or when the crop is not there? As I told you when we studied the biology course, that the weeds are a very important source. They act as a reservoir source of the viruses. Mostly all weeds are infected by a lot of viruses. So when there is a not particular crop in a season, any weed plant is growing nearby, plant are going to stay on that weed plant for a longer time, right? So plant viruses that are airborne, they are transmitted by insect or a mite vectors or sometimes by contact. And there are some soil-borne also, they are transmitted in the soil by the nematodes or the protists also. So all these factors we need to study. Then understanding its epidemiology. So how different environmental factors affect pathogen and disease, and what is the pattern, right? So how with change in the environmental factors, this 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 is impacting disease, whether it is increasing, whether it is decreasing, how it is in the dry weather, how it is in the maybe in the monsoon season, or how it is in the winter season. So all those factors we need to study, right? So again, then we need, this is similar, like when we studied the forecasting for fungal and bacterial pathogen, we also study that what are the things which we require to, for a disease forecasting. What are the factors we need to take into consideration, right? What are the losses caused by the pathogen? What, whether the control measures are available or not, right? That we studied last time. So here we need to define the prediction objective, that what are the objectives, how we are going to predict it. Then we need to implement that predictive framework. We need to validate the predictions also. Then we need to analyze the parameter sensitivities also. Then we need to its application part, that how actually these points can vary with the different pathogens and according to the people who are working on a particular model. So we need to prioritize the things that, right, how we are designing a model, whether this model is going to fit in a present scenario, what are the management practices available, what is the application of this model that is going to be there, right? So we need to do. So there are certain examples here which were developed for certain plant viruses such as cucumber mosaic virus, lupin pathosystem. So this scenario for modeling involves internal virus source. Then what is the virus source basically? Then non-persistent vector transmission by different apid species, right? So last time when we discussed the transmission, we discussed that there is a persistent, non-persistent, and a semi-persistent way of a transmission by the vectors, especially when they transmit viruses, right? So in this case, is a non-persistent vector transmission by apid species, which include both colonizing and non-colonizing type, and a polycyclic spread pattern, right? How in a different cycles in a season they can spread. in which annual crop is grown under cool, late autumn and to spring conditions. So in a different environmental conditions, they try to study the pattern. Then lupin is important grain crop in the southwest Australian grain belt, and CMV causes losses up to 60%. So that means the losses were very high due to this particular virus. So that is why they thought of developing a disease forecasting program for this. Then CMV is a seed borne in lupin. So what does that mean? That means it is in the seed. The pathogen is in the seed. So usually in seeds, those plants which produce seeds, those what does the farmers do? They keep some seeds from the previous season to grow in the next season. So if the pathogen is already present in the previous season in those seeds, he's going to grow those, use those seeds for sowing in the next season. So he is unknowingly transferring or you putting those pathogen infected seeds in the field, and definitely the plants which will be grow, they will already have the pathogen, right? So CMV is a seed borne in lupin. Seed infected lupin plants acts as the primary virus source from which the aphids acquire, and then they can spread it to the healthy plants. So aphids, when they feed on these infected plants, they'll acquire the virus, and then they'll spread going to, when they are going to again feed on the healthy plants, so they are going to transmit the viruses, right? So principal vectors, there are a number of vectors here. There's a blue green, there's a green peach vector, there's a corn leaf vector, number of vectors which transmit this virus, right? The extent of epidemics in the crops and yield losses differ widely with the district and the year. So this is again when we talked about the prediction in a disease forecasting. So last time also we said that it is never the same, right? This year it could be different, the next year it could be different, and this epidemic can also vary from place to place depending upon the weather condition. So key driving factors are magnitude of primary source within the crop, how much virus is already present. Primary source is means the from which the infection will take place. It is present in the crop. Vectors first arrival time related to the crop emergence. So when are the vector going to appear in the field, right? Late or early. So if they are going to appear very early when the plants are grown, so definitely spread will be more. If they are going to appear late, then the losses will be less, right? Abundance and activity of the vectors in the crop. Aphid species involve various climatic factors, which include the influence of temperature, rainfall, and the wind on aphid numbers also. Aphid behavior, virus transmission, and cultural practices determining plant density. Plant density is always very important. So when growers also farmers they grow a plant in a particular area, so after some time they do a practice called thinning of the crops, right? So thinning is, there are many reasons to do that. First reason is that if plants are grown or they are very dense, so they will not get proper sunlight, they will not get proper nutrition from the soil, so the yield will not be very good. So that is one reason that thinning is done. And another reason is that the transmission rate is higher for any pathogen, whether virus or a fungal pathogen, if they are very densely grown. So for that reason also the thinning of the crops is required, it is recommended, right? So, as simulation models which collates the complex interactions which are involved in CMV spread by aphids to forecast aphid outbreaks and virus epidemics in lupin. So they study various factors, and on the basis of those factors, they are able to forecast this particular disease. Then rainfall and temperature data for a given locality are major driving variables for medical, because it varies, right? In a particular locality, rainfall can be more. In another locality where this crop is grown, it could vary from area to area or from state to state. So the simulation is temporal and uses daily time steps over a calendar year. So assumptions are outputs are for a crop without any neighboring lupin crops, or the only CMV source is seed infected lupin plants, or third is the time of first aphid arrival in crops depends upon amount of the rainfall and temperature during late summer, early autumn. And then virus spread between the plants is by colonizing or non-colonizing winged aphids, how they are being spread, right? Then vector species are not accounted for individually, but they are grouped into colonizing or non-colonizing types and with different acquisition and transmission efficiency. Acquisition, acquisition is different, right? for every vector to acquire a vector, there's acquisition time, right? So for they need to feed on a particular crop for a certain period of a time to acquire the vector. If they feed less than that time, they are not going to acquire the vector. So that acquisition time is also very important. That for how much duration they will feed on a particular crop, right? So each time an aphid flies within the crop, it lands on a different plant from one it left, which may or may not be effective. Again, this depends. In order to infect another plant also, it needs to feed on that healthy plant for a certain period of a time. Otherwise, it is not going to transmit the virus. So all those factors are being reported, all those factors are being studied, and they are being correlated. So once a healthy looking plant is inoculated with CMV, is a latent period of 14 days. So this is until then the symptoms doesn't okay. It is called as an incubation period also. That after that only the symptoms will be shown on the plant, right? So infection can occur anytime from crop emergence until the senescence. Senescence means crop emergence means till the plant grow in the field, till the senescence means till the plant dies. Age, right? Aging, falling of a leaf, drying of a plant. So this model uses daily rainfall to calculate an index of aphid buildup on the plants in each locality before growing season, and then it forecasts timing of aphid immigration into the crop. Then the subsequent aphid buildup and movement within the crop, the CMV spread from infected source plants, yield losses, and percentage of harvested seed infected. They do all kind of a calculation. Losses कितना होगा, कितना आपका transmit हुआ था, कितना losses हुआ, everything is being done. Then model simulators, they were validated by comparing them with the data collected from the field experiments and validation blocks at 6 sites over 16. You see here the 16 years is a really long time. So they have been studying that particular disease for at least 16 years and at not only one site but at different sites, right? So again, representing different rainfall zones, geographical areas, and a range of free-growing season rainfall scenarios, sowing date, infection percentage, plant density, everything, every kind of a pattern or every kind of a practice that we do in a field for crop growing, cultural practices or any other, it is being recorded, right? And then certain variations are being see they in order to study a particular disease in a particular area, there are different ways, right? First is that you study in a natural field where it is happening. The another way is that you create experimental fields for that, right? You specifically create experimental fields, and then you can vary the certain activities that you are going to do. Cultural practices, maybe in one field sowing date थोड़ा early कर लिया, other field में sowing date ये रखा, third में थोड़ा late कर लिया, right? ऐसे ऐसे आप variable फैक्टर्स को वेरिएशंस करोगे, वेरिएबल्स को स्टडी करोगे कि उससे क्या इम्पैक्ट आया डिजीज पे. It looks as a very small factor, but this definitely impact the disease a lot later stage. So इस तरह से they study all kind of factors by varying them in an experimental field and compare them to the natural conditions also. Then they have a tomato spotted wilt virus, a peanut pathosystem. Tomato spotted wilt virus is a toxicovirus and it causes a lot of losses. And this virus again infects a lot of vegetable ornamental plants, right? Again, here the modeling involves external virus source, persistent transmission. Last time हमने पढ़ा non-persistent transmission by aphid. In this case, there is a persistent transmission by Thrips species and a monocyclic spread of a pattern, right? So where an annual crop in spring is sown in a subtropical country, this is a monocyclic pattern. Then again here rainfall and temperature were the critical weather variables which were studied, and they studied how with these factors the disease was changing. Then key factors in achieving success when developing predictive models for epidemic of a particular virus crop ecosystem are: before starting, ensure availability of data of high quality from different growing seasons and climatic zones that provide epidemiological information which cover yield loss data should also be included in that, right? Then identify the primary epidemic drivers and those of secondary importance for a pathogen system so that critical assumptions can be established to allow an epidemiological model to be devised. So epidemic drivers means what are the factors which could lead to any epidemic-like situation. So we need to identify those factors. Then we need to incorporate weather data by using combination of mathematical expression with basic statistical algorithm. So as I told you last time also that this epidemiology or disease forecasting that I'm telling you is theoretical. Otherwise, when we talk actually about the disease forecasting and epidemiology, it is all based on statistical calculations and computer-based programs. So there are a lot of formulas which are being used, or statistical formulas which are being used, or programs in which you feed your data and then certain kind of inferences are being drawn out of that, right? So this is disease modeling or disease forecasting is all about mathematical calculation, right? So by using simulation approach, when modeling individual components of a system, a hybrid structure can be created, which is tolerant of extrapolation and lends itself readily into incorporation of a weather variable. So we use computer simulation programs in order to forecast disease accurately. So these basically what they do, they make a computer-based program. Then they feed all kind of a data which is available from the maybe 5 to 6 year in that particular program, computer-based program, right? So in that, what kind of a data? Like if the temperature, for example, for particular pathogen, they say if the temperature is 25 degrees Celsius, the pathogen impact is maximum. The vector population is maximum, right? So what was the rainfall at that time, right? So this way, a proper systemic or a system is being created where all the kind of information about that particular disease which is happening from the past few years available. And if we put the present scenarios, for example, if I say that right now the temperature is 28 degrees Celsius, the rainfall is maybe how much 3 mm or 4 mm, and the relative humidity is maybe 80% only. So I'll put that data in that, and I'll ask computer whether are there any chances that whether this disease will take place. So it will going to study all the data which is already present in there and compare the when was the disease maximum, in which combinations the disease was present. So all those calculations will be done and I get the answer, right? So the model validation again involves virus epidemic data collected over several years, climatically, geographically, with distinct sites with the model prediction for each scenario. If the model predicts a range of diverse outcomes well, it is sound. The validation block approach is well suited to collect such data. So definitely, see, again, we are when we are talking about the forecasting, we are talking about the probability, right? So we always say that there is a probability that this disease might take place maybe within a 5 days or within a 10 days. So it is never sure. Right? They are not saying that, okay, now disease is going to happen 100%. No, they are just telling us the probability that disease might take place after this time or maybe within this time period of range, right? So this is useful because during that time, farmers or growers, they can use whatever management practices are available, which can be used before the disease is taking place, right? So they'll try to use every possible way which can prevent the disease to take place, or which can reduce the losses which can be caused by a disease when it is taking place. It could be the fungus phase, it could be the cultural practices, it could be any other thing, right? It could be the vector control in case of a viral pathogens, because viral pathogens are transmitted by the vectors. So if we can manage the vector, we can manage the disease. So whatever methods are already available, the farmers or growers will try to use or implicate those methods in their field in order to save their crops, right? So with this we end the this particular module which talks about the plant disease epidemiology and disease forecasting, right? So this is all about this whole module, disease forecasting, and this. If there's anything which you feel you need to study, or you need more clarification, or you need more lecture on that, please let me know. But in order to do that, you first need to grow to what is being taught in the class, right? So again, I'm telling you, uh, so next week we have an exam also. So till today, whatever we have covered in plant pathology will cover in the exam. That means up to the epidemiology module, third module, I guess this is. So we'll till this you'll get in the exam, and questions will be from MCQ or one line or one word to maybe 5 marks also. So just prepare accordingly. A thorough study. I want you to study thoroughly. It's not just ऊपर से पढ़ लिया. No, a thorough study of a particular this whatever I've taught you in the class. You should go through that and will do that, right? So with this, I finish off this module also. And if you have any questions, I tell you 10 times in a class, please ask your questions in the same class or in the next class or in whichever class you feel. अगर आपको लगता है कि आपको कोई चीज समझ नहीं आई, you can ask me 10 times again, right? So that's all from my side. And also one thing, I've put one assignment. I don't know if you've seen that, but when I was just checking through I was just going through the evaluation part, at how it is being divided, the marks for assessment. So there I found that there's a field work also. So that field work, there is 20 marks, right? So I've given one assignment, which is interesting also, and I don't know, but I want you to do that way, right? So what you will do, you will look at the plants around you, maybe in the park or whatever plants. It could be the wild plants, it could be the weed, anything, right? You just try to see the symptoms, whatever symptoms you find, and whatever we have studied till now for anything. You'll take pictures, at least I want 15 pictures. You try to identify the pathogen. You can study the name of the, पहले तो आपको वो plant का नाम ढूंढना होगा, right? If it's a weed also, you'll Google these days. There are a lot of sites, you'll find the plant name also. Then you check whether what kind of a diseases are already available or already reported from that plant. Then you'll try to correlate that symptom. मेरे को इंटरनेट से कोई पिक्चर्स नहीं चाहिए. I'll know if you'll get it from internet. I want your mobile pictures. आपके मोबाइल से क्लिक हुई हुई पिक्चर्स चाहिए मुझे. The deadline is 28th February, so I really hope if we open in the February, so then we have their organic agriculture farm. So I'll take you to that farms also. And even in Amity also, when I see the ornamental plants grown throughout the Amity, very prominent viral symptoms I see on those plants. So if it opens, it is fine. You can click the pictures around that areas also. Start exploring your areas also nearby. I'm not saying that go out or extensive. When you go out for something, just do that. And then you'll make a PPT, a proper PPT of that. And 20 marks are a lot of marks, right? So make sure that you make in a proper way and marks will be given according to that. So this is your field work for plant pathology, and you're going to submit it by the end of 20th February, right? At the end, right? Okay, so fine. Let's go for our attendance now. Yes, there's a Shakti. Yes.
Good morning, ma'am.
Good morning, Shakti.
Yes, ma'am. So I have a question.
Mhm.
Yes, ma'am. So can we predict a disease which is like the first time, which has never uh, occurred before, or which have which symptoms we never have seen, or because then we don't have any data, or we don't even know which microorganism is causing that disease?
No, Shakti. This is not possible. We cannot predict a disease which has not happened earlier. Because see, when we had studied about the disease forecasting, we studied that we need to do at least 5 to 10 years of a research on a particular disease in order to predict that particular disease in a particular area, right? So that means predicting a disease is not possible. But let me tell you, since viruses are pathogens which mutate very fast, and there is always a possibility of occurring some new strain of the viruses. But human viruses, if we talk about, then we definitely expect, or we cannot predict it very accurately, but we know somewhere that this is going to happen, right? For example, in this coronavirus, when it was earlier found in 2004 or somewhere that time in the East Mediterranean regions of they were I don't remember exactly the disease, right? So after that, only the scientists, they started working on that, and they knew that if this disease or this pathogen occur in some other form, it could lead to a pandemic situation. But then prediction is something which we cannot do, right? We know that this is going to happen, but when this is going to happen, that is not possible, and especially in plant pathogens or a plant viruses or in case of a plant pathogens, no, I don't think it is possible. No, not without studying, right?
Okay, thank you, ma'am.
Okay, so if anyone have any other question, please go for it. Okay, fine. So just just uh, just try to go through it, and you know, this is what I'm telling you again and again. Just try to read the things that we discuss in the class. Right? The more you read, maybe related articles or maybe journal articles only, the more you'll understand, right? So okay, fine. Let's do the attendance thing. Adish Mishra. Adish को क्या हो गया आजकल? I don't get to hear his voice. Thoiba,
Okay, ma'am.
Ayushi,
Present, ma'am.
Sam,
Present, ma'am.
Devanshi. All of you, please switch on your cameras also. Devanshi, Ishita, yes, Ishita is there.
Present,
Devanshi
ma'am.
is there. Chanvi
Present, ma'am.
is there. Kshitij, Manaswini,
Present, ma'am.
Namrata,
Ma'am, Namrita is having network issues. She messaged me.
why don't she message me then since I'm her teacher?
Present, ma'am. Present.
Nandini,
Present, ma'am.
Nehal is there. Rupal,
Present,
Sahiba,
ma'am.
Sahiba,
Present, ma'am.
Anjana,
Present, ma'am.
Shakti,
Present, ma'am.
Shivani, Tanvi,
Present, ma'am. Present, ma'am.
Kshitij, Kshitij,
Present, ma'am.
Kshitij, आप तो अच्छा गाना गाते हो, मुझे तो पता ही नहीं था आप गाना भी गाते हो. Yesterday I came to know you sing really well.
Thank you, ma'am.
Vivek, Yukta, Yuvraj.
Present.
Okay. Okay, guys. So just remember, study. You this question paper will not be easy, and I'll make sure it is not direct. जिससे आप Google देवता की मदद ना ले सको. I'll make sure that, right? Yeah. So it will be journal only if you've studied and understood the things properly. Otherwise, you will not be able to attend. I'll make sure this time, right? कि आपने पढ़ा हो तभी आप आंसर कर पाओ. Direct questions I'm not going to ask in this. So make sure at least plant pathology. So please prepare well for this exam. Remember your assignment of this field work also. This is important, 20 marks, right? Okay, guys. I'll see you then maybe next week, and I really hope that in February things get open and I get to see you guys in the university, right? So at least 1 month you guys should be there. Okay, bye bye. Thank you so much.